Here we have a slightly more complicated point load problem that we're going to draw a shear and moment diagram for. And I've laid it out, and these are the reactive forces. I'm not going to go through that. We'll just assume you know how to do that. Once again, we sort of go through the same process. We're going to take the guidelines down from every point of concern, every support point, every load point. You're going to use a ruler. I'm getting better already at drawing lines on the screen. This allows us to be in scale, and scale is important for this. So now the first thing we're going to do is shear, and we're going to look at going from left to right. Need some practice on horizontal. Yeah, better. All right. So we're going to go from left to right, and as our eye goes, we're going to record the loads on the shear diagram. And we're going to remember that up on the left and down on the right is positive, down on the left, up on the right is negative for shear. So I've got it down 2, and so I'm going to go down 2 boxes. As I go from left to right, I don't hit anything until I hit the 6 kips going up, and I don't hit anything, so I see the 6 kips going up, so 2 and 4 more. So this is minus 2 kips, and this is 4 kips. Minus 2 to 4, 6 kips. As I keep going, I don't do anything until I go and I hit this 4 kips, and I don't hit anything until I hit that 4 kips and I go down. Once again, I keep going from left to right and nothing until I hit the 2 kips going down. 2 boxes. Carrying on till I hit the 2 kips going back up. Back to 0. Now, we could copy these dimensions, 5 feet, 5 feet, 10 feet, 5 feet. And we're going to see the size of the boxes. And I'm just going to put the magnitude, not the units. And the units in the boxes are kip feet. This is 20. This is minus 10. This is minus 10. And we're going to check ourselves once again from going left to right. And we're going to add up. Do we end up with 0? Minus 10 plus 20 is plus 10. Minus 10, we end up with 0. So we net out at 0. Put the So now we're going to do the moment diagram. No, still not good enough. I'm going to work on this. Better. So we're going to do the moment diagram. We're going to do our key points. And once again, the moment is the sum of the area to the left of the point. So we're going to do this point. The area to the left is minus 10 kips. So minus 10, I'm going to count boxes. And it goes down for every foot. It goes down the same amount, or it goes down by 2 kips. Straight line. This is minus 10 kip feet. Now here, I want to know where I'm going to be here. So I'm going to be minus 10 plus 20, which is plus 10. So my other point is going to be plus 10. And once again, it's a straight line from minus 10 to plus 10. And the idea here is I have a net of 20. So I've gone up 10, up 20. So that's same up 20. Here, there is no change in area. No change in area to the left from here, here to here. There's no change in area. The area is still plus 10. So we're going to cut across here, plus 10 kips. And then we've got to go measure the area here, and we've already did, we already measured the area there, and we know it's 0, so it goes down to 0. This is moment. I forgot to label this. Don't want that. So labeling it goes from minus 10 to plus 10 back down to 0. And the M max, we're just going to get into the habit of writing out M max, is positive 10 kip feet. We would say it could be either positive 10 or minus 10 because we're looking at the absolute value, but that's how we do, because that's unless we have a asymmetrical section, positive and negative moments we design for the same thing, and we'll get into that. So here we have a slightly more complex shear and moment diagram. The next step is to start to work on uniform loads, but we'll get to that in a minute. Shear and moment diagrams.